Nowadays, the stars in our night sky are just a little, often unremarkable, bright dots. They just shine, it's a matter of course. Occasionally, people try to find a constellation or a particular star, at least just for the sake of interest, and even more rarely, they are used for orientation. But this was not always the case. Do you know what a heliacal rising is? It is when a celestial object, be it a star or a planet, after a certain period of absence in some part of the sky, as the Earth rotates, appears again for the first time. And not somehow, but just before sunrise. As the poet would say, sunrise in the rays of the morning dawn. So, long ago, in ancient Egypt, people paid attention to one interesting feature: such first rising of the star Sirius occurred about the same day every year. Moreover, after this event occurred the flood of the Nile River, and was of particular importance to them. The Egyptians found it out and began to consider the first rising of Sirius as the beginning of the new year. In the more or less same way, Sirius was used by the ancient Greeks and Romans. Today, the heliacal rising of this star no longer coincides with the Nile flood. But the point is as follows: at that time, very little was known about the stars. But they were an integral part of human life. Everything has changed now. And we can already tell a lot about famous stars in our sky like Sirius. It is probably one of the most popular stars on Earth, mainly because it is the brightest in the night sky. Sirius is not too far from us, at a distance of only 8.6 light-years from Earth. That is why it is the brightest for us, but in addition to its proximity to the solar system, it also has a luminosity about 25 times higher than that of the Sun. However, everything can be seen through comparison. If we take Rigel, its luminosity is 120,000 times higher than the solar one, or Arcturus, 170 times higher than the solar one, then Sirius is not so bright. The Sirius system is located in the constellation of the Canis Major, and it was formed around the main character of this video. Sometimes it is called the dog star, but I think this is too vulgar. Here's what I thought. Since it is the core object of the constellation Canis Major, and since it is associated with these beautiful animals, then Sirius is a good boy. A good boy star sounds good and clear, doesn't it? On the other hand, it is not the case for us, because Sirius is a binary star system, consisting of component A, a white star of the main sequence, and component B, a white dwarf. By the way, it is the closest white dwarf to the Sun. In this Hubble telescope image, we mostly see Sirius A. But do you see this bead right here? That's Sirius B. And these cross-shaped diffraction needles and rings around the main star and the little ring around the second star are artifacts from the telescope's imaging system. Both stars revolve around each other for a period of 50 years at distances ranging from 8.2 to 31.5 astronomical units. The average distance between them is about 20 astronomical units, which is about the same distance as that between the Sun and Uranus. In 2019, the stars were at their maximum remote distance, and in 2044, they will approach each other again. The presumed age of Sirius A is from 237 to 247 million years, which is much younger than our star. Actually, in this characteristic, the Sun surpasses many stars in our sky. However, compared with Sirius, except for age, the Sun has no other superior positions. Sirius A is about twice as massive and 1.7 times the radius of the Sun. Its estimated surface temperature is 9,940 K. Sirius A is a star whose spectrum shows strong absorption lines of elements heavier than helium. Its iron content is 316% of that of the Sun. The high metal content is thought to be mostly present in the upper layers of the atmosphere, rather than in the entire star. In turn, Sirius B is much smaller than its companion, still being one of the most massive white dwarfs, not only closest to Earth but in the whole universe. It was only the second white dwarf ever discovered, in 1959. The first was found in the triple star system 40 Eridani. The mass of Sirius B is only slightly greater than the mass of the Sun, and its radius is only 0.0084 of the radius of the Sun. In other words, it has the mass of the Sun packed into the size of the Earth. Current estimates of the surface temperature are about 25,000 K, and will gradually decrease over the next 2 billion years. The star is about 228 million years old and is a more powerful source of X-rays than Sirius A. Here's an X-ray image of the star system. It shows two sources and a pointed pattern. This is also an artifact. The bright source is exactly Sirius B. Most likely, Sirius B was once the most massive star in this system, and it was very different from the one we can observe nowadays. The system consisted of two bluish-white stars in an elliptical 9-year orbit. Sirius B was originally a star with a mass of 5 solar masses, then evolved from the main sequence and became a red giant about 120 million years ago. It eventually lost its outer layers and became a white dwarf. By the way, the same fate awaits Sirius A in the future. The star will run out of hydrogen in its core and turn first into a red giant and then into a white dwarf. For a long time, it was thought that there was a third star in the system. There was speculation that it was a very small star with a mass of 0.06 solar mass in a 6-year orbit around Sirius A. Observations in 1995 led scientists to conclude that there was probably the third star with this mass and orbital period in the system. But more recently a Hubble Space Telescope study has eliminated the possibility of any object larger than a brown dwarf or a large exoplanet orbiting Sirius A or Sirius B. This was followed in 2015 by observations with the Very Large Telescope, which, in turn, also ruled out the presence of giant exoplanets with masses between 4 and 11 Jupiter masses orbiting the host star. Maybe the capabilities of our telescopes don't yet allow us to see clearly whether there is a star or an exoplanet. In the future, it will become clear. Right now, the Sirius system is slowly approaching us and will gradually become a little brighter over the next 60,000 years. After that, the system will begin to recede and become slightly fainter, though Sirius will remain the brightest star in our night sky for the next 210,000 years. And only then will it pass on that status to the beautiful Vega. This image shows us how the Sirius binary star system might appear to an interstellar visitor. By the way, we also see 3 bright stars in the background here. Altair, the white dot above Sirius A, Deneb, the dot at the top right, and Vega, just below Sirius B. Also, if you look closely, you might notice the little dot just below and to the right of Sirius A. That's nothing else but our home star called the Sun. In all these thousands of years, Sirius hasn't changed much, which is not the case for mankind. Today, in the 21st century, the stars have become closer to us, because we can examine them thoroughly and describe them in detail, but paradoxically, they have become further away. They have ceased to be of interest to most people. Of course, there are astronomers, scientists, and enthusiasts like you and me. Did the ancient Egyptians dream of traveling to Sirius? I think so. Could they have had the information we've just learned? Certainly not. I think all ancient civilizations, familiar with astronomy, didn't imagine the future of mankind as it is now, and we imagine a future in which spaceships are commonplace, as well as the colonization of other worlds, where you can go on vacation not to the seaside, but to, for example, Proxima Centauri. Meanwhile, the word star often refers to a completely different thing in our modern world.